There are two questions given here, but in exam you can choose either first one or second one. We start with first question. Here the question is find the area of the foreign region using integration. And we have given that x comma y such that y less than or equal to mod x plus 2 and y greater than or equal to x square. We are going to find the region bounded by the parabola y greater than or equal to x square and V-shaped line y less than or equal to mod x plus 2. Since we have y equal to mod x plus 2, we are going to split into two linear functions depending on the sign of x. For x greater than or equal to 0, then y will be x plus 2. For x less than 0, then y will be minus x plus 2. First, let us draw the graph for finding the region between the given parabola or the V-shaped line. Let us get the coordinate point for drawing the parabola y equal to x square. So now we are going to take the value of x and y here for drawing the graph. So now let us take the value of x is minus 2, minus 1, 0, 1, and we are going to consider two words. If the value of x is minus 2, then y will be 4, and x is minus 1, the value of y is 1, and x is 0, y also 0. If x is 1 and y is 1, x is 2, then y will be 4. Now for drawing the line, we are going to consider the value of y equal to x plus 2, and the other thing y equal to minus x plus 2. So first let us take the line y equal to x plus 2, find the coordinate point x and y here. So we will take x here and y here. If x is 0, then y will be, if x is 1, the value of y is 3, and if x is 2, the value of y is 4. Now we'll take the points y equal to minus x plus 2, the equation. So now we are going to take the value of x and y. If the value of x is 0, then y will be 2. And if x is minus 1, the value of y is 3. If x is minus 2, then the value of y will be 4. Now let us draw the parabola line here. Let's take this as x-axis and x dash. So here we have y-axis and y dash. So let us take this as center 0, 0 and the point 1, 2, 3, 4, 5, 6. Here we have negative 1, 2, 3, 4. Here we have positive 1, 2, 3, 4, 5, 6. And down we have negative 1, negative 2, and so on. Let us draw the parabola first. Here the point is minus 2, 4. So here the value of x is minus 2 and y is 4. So we have the point minus 2, 4 here. And the next one is minus 1, 1. So we have minus 1, 1 here. And the center is 0, 0. The other point 1, 1. And the next one is 2, 4 here. So if we connect all the points, we get the parabola like this. This is equal to x square. Now let us draw the line. So y equal to x plus 2. Of course, the coordinate point is 0, 2. So here we have 0, 2. And the next one is 1, 3. So here we have 1, 3. And the other point is 2, 4. So if we connect these 2 points, we'll get the line like this. Now let us, for all these points, 0, 2. Again, x is 0, y is 2. We have here same point. And minus 1, 3. So we have the point here, minus 1, 3. And the next one is minus 2, 4. So we have the point. So if we connect these 3 points, we will get the line like this. Now we are going to find the area between these V-shaped line and the parabola y equal to x square. We are going to find area of this particular region, shaded part. So before finding the area, let us find the intersection part with y equal to x plus 2 and y equal to minus x plus 2. So for finding the intersection point, we are going to equate y equal to x plus 2 and y square equal to x. So if we equate those, we get x square which is equal to x plus 2. And we get x square minus x minus 2 equal to 0. If factorize, we get x minus 2 into x plus 1 which is equal to 0. So here the intersection points are x equal to 2 and x equal to minus 1. So here we have the intersection point x equal to 2. Now on the other side, we are going to find x square, which is equal to minus x plus 2. And x square plus x minus 2 equal to 0. If we factorize this, we get x minus 1 into x plus 2, which is equal to 0. And the intersection points are x equal to 1 and x equal to minus 2. So on the other side, the intersection point is x equal to minus 2. That is minus 2 comma 0, and this side 2 comma 0 is the intersection point. Now we are going to find the area of this particular region using this intersection point. Now let us find the required area, which is equal to 2 times of the integration of the limits from 0 to 2, x plus 2 dx, minus integration of the limits from 0 to 2, x square dx. If we integrate this, we get 2 times of x plus 2 the whole square divided by 2, minus x cubed divided by 3, and limits from 0 to 2. So if we apply the limits, we get 2 times of 6 minus 8 by 3. And if we simplify this, we get 20 by 3 square units. This is the required area of the region between V-shaped line and the parabola y equal to x squared. Now let us solve second question. Here the question is using integration, find the area for triangle whose vertices are 1, 0, 2, 2 and 3, 1. So given the vertices of the triangle A, B, C, we can write A is 1, 0 and B is 2, 2 and the point C is 3, 1. The vertex A is 3, 1. By plotting these points on the graph, we give the triangle and the state this is x-axis, y-axis and the point 1, 2, 3. So here we have 1, 2 and 3. First the point is 1, 0. So we'll be here we'll be having 1, 0, the point A, and point B which is 2, 2. So here we'll be having 2, 2. So this is B, 2, 2, the vertices. And the last one is C, 3, 1. So here we have 3, 1. The vertex is C, 3, 1, the vertex. So if we connect all these points, we'll get the triangle like this. Now the question is find the area of this triangle. So we are going to find this shaded part, area of this portion we are going to calculate. We know that equation of line between the points x1, y1 and x2, y2 is y1 minus y1 divided by x minus x1, which is equal to y2 minus y1 divided by x2 minus x1. Now we will find the equation of the line segment AB, which is y minus 2 divided by 0 minus 2, which is equal to x minus 2 divided by 1 minus 2. Here we have minus y plus 2, which is equal to minus 2x plus 4. And 2x minus y, which is equal to 2. And we can write 2x minus 2, which is equal to y. So the equation of line segment AB is y equal to 2x minus 2. Similarly, segment BC, we can write y minus 0 divided by 1 minus 0, which is equal to x minus 1 divided by 3 minus 1. If we simplify this, we get y by 1, which is equal to x minus 1 by 2. And 2y, which is equal to x minus 1, and y equal to x minus 1 divided by 2. So this is the line segment of BC, y equal to x minus 1 by 2. Now let us write line segment CA. We have y minus 2 divided by 1 minus 2, which is equal to x minus 2 divided by 3 minus 2. And again we can write y minus 2 divided by minus 1, which is equal to x minus 2 divided by 1. We simplify, we get y minus 2 equal to minus x plus 2. So we have y equal to minus x plus 4. So therefore the required area is area enclosed by line AB and x-axis plus area enclosed by line BC and x-axis minus area enclosed by line CA and x-axis. So we can write 2 times of integration of the limits from 1 to 2, x minus 1 dx plus integration of the limits from 2 to 3, 4 minus x dx minus 1 by 2 times of integration of the limits from 1 to 3, x minus 1 dx. So if we integrate, we get 2 times of x minus 1 the whole square divided by 2, and the limits from 1 to 2 minus, we get 4 minus x the whole square divided by 2, the whole part limits from 2 to 3 minus 1 by 2. If we integrate, we get x minus 1 the whole square by 2, and the limits from 1 to 3. So if we apply the limits, we get 2 and 2, we can cancel out. So if we apply the limits, we get 2 minus 1 the whole square is 1. And again, if we apply the lower limit, we get 0. So finally we have 1 minus, if we apply the limits here, we get 1 by 2 minus 2 minus 1 by 4 into 4. We simplify this, we get 1, 2 minus 2 is 4, minus 3 by 2. So minus 10 of minus is plus. So 1 plus 3 by 2. We can cancel out this one, minus 1. So we can cancel out 1 and minus 1. Finally, we have 3 by 2 square units. So this is the area of the triangle whose vertices are 1, 0, 2, 2, and 3, 1. So the final answer is 3 by 2 square units.